I had a few questions from a few students about question 20 from chapter 2. This is the material that we just started. We just got into this at the end of lecture this week. So we haven't had much chance to practice these calculations, which makes the calculations a little bit more tricky. And this one is a little bit of a different version than the one we looked at class. And so basically they're telling you bromine has two naturally occurring isotopes, bromine 79 and bromine 81. They tell you that bromine 79 has an exact mass of 79.91 AMU and is approximately 50% of the abundance of all the bromine. And then it tells you to calculate, it asks you to calculate the exact isotopic mass of bromine 81. And one of the things that makes this problem a little bit more challenging is they don't give you the average atomic weight for bromine. And so to make our lives a little bit easier, the average atomic weight for bromine is 79.90 AMU. So to kind of set it up like we did in class, we've got bromine 79 and we have bromine 81, and we know bromine 79 has an exact mass of 78.91833371 AMU, and its abundance is 0.5069. And so here's our unknown, right? We don't know the isotopic mass of bromine 81, but we know that if we multiply the isotopic mass by the abundance and we add those two weights together, the sum of those two weights should be 79.9 AMU. So we can find that mass of bromine, the contribution of bromine 79. We multiply those two together and we get approximately 40.0037 AMU. And as you can see, we've got a few other unknowns in this calculation. Well, we can figure out next, right? We know the sum of both of these should be 79.90. So we can take 40 and subtract it from 79.90 to get the contribution from this isotope, from bromine 81. So we subtract those two and we get 39.8962 AMU. Now we're getting closer to solving for what is the weight of this isotope, right? And the last step to do that calculation is to realize that bromine 79 and bromine 81, the sum of these two is 100% of all the bromine. So if I have 50.69% here, that means the remainder, right, the sum of these two needs to equal 1 because this is 100% of all the bromine between these two isotopes. So 1 minus 0.5069 will give me the percentage abundance of bromine 81, and that's about 0.4931. So now I can plug that in here, and now, right, I've got an algebraic equation where I've got 0.4931 times x equals 39.8962 AMU. I'm going to divide both sides by that abundance, right? So 0.4931, and I'm going to get x, which is the isotopic weight of bromine 81, to be approximately 80.9089 AMU. So this was a little bit trickier than the question we did in class, but we can still figure it out because we know the average atomic weight of those two isotopes. And we can find the contribution from bromine 79, which lets us find the contribution from bromine 81, and then work backwards because we know these two fractional abundances need to equal 100% of the material to allow us to find, based on that, what is the weight of this isotope of bromine 81. So hopefully that helps with that problem. And if you were stuck on it, it's okay because we just started this material, and this is a little bit more complicated version of the problem we looked at in class. But hopefully this helps.